that first one, 3 to the negative 2. Hopefully by now we're okay with the idea that negative exponents don't mean negative numbers. Negative exponents mean reciprocals. There's kind of two ways you can look at this one. If you realize that it's 3 to the, we'll highlight these two things separately. If you want, when you have a negative exponent, you can make it into a positive exponent. So you can write this as a 2, as long as you write the base as the reciprocal of what you had. So if I change this, what's the reciprocal of 3? 1 over 3. So those two things are equivalent. Something to a negative power is the same as its reciprocal to a positive power. That's one way to think about negative exponents. And 1/3 squared, 1/3 times 1/3 is, well, you could write it as 1 squared over 3 squared, and that gives you 1 over 9. The other way you can think about it is, or the other way you can write it, slightly different. You might realize right away that 3 to the negative 2, if you imagine like already as part of a fraction, if you imagine that there's a 1 underneath here, if you have a negative power on the top of that fraction, you can rewrite it as with that on the bottom of the fraction as long as you change it to a positive. So if you imagine that you have this fraction and there's 1s there, instead of having that 3 to the negative 2 on top, you can have 3 to the positive 2 on the bottom. Right? So you have 1 over 3 to the 2. That's what it is, right? 1 over 3 to the 2. If you want to write it like that way right away, which is 1/9. Okay? Takes a while for this negative exponent stuff to sink in and really click. But you just have to realize there's no negative sign on there. It's not a negative number. It means reciprocal. Right? This second thing here, there's a couple different ways we can look at this as well. You can either just use exponent laws right from the start, and you can simplify this top part here. Okay, so you can do something with the top part first, and then leave this alone. So you can rewrite the whole thing as, you can write this as x to the negative 5 plus 3 on the top. Right? You can just add those things on the top, and x. You can actually call this x to the 1 on the bottom. Right? So this is the same as what's up above. This is the same as what's up above. And then you simplify that x to the, this is equal to x to the negative 2, x to the 1. So you still just have that on the bottom, have this on the top. Okay, and then simplify it once again here. If you're dividing two powers, you can just subtract those if you want. Negative 2 minus 1, which is x to the negative 3. I've already got 5 steps here. I think a lot of times people have problems with this because they try to jump right to the final answer without doing anything in between. I can't do that. I end up making too many mistakes that way, and I think some of you guys are the same. It's better to just write it down, then you avoid mistakes. X to the negative 3 is the same as 1 over x to the 3. That's the simplest way to write that thing with a positive exponent. That's one way you can do that. I want to show you a different way, so I'm going to move this for a second temporarily here, down here. And we'll get to that in a minute. This one, the other way you can do it here, I'm going to rewrite it. So I'll put a big or here. Or if you have x to the negative 5 times x to the 3 over this, you can just think of each of these things separately. So let's use, let's make this one blue this time, this yellow, and we'll use another color here, pink, for that. Okay, so this is a different way to do this. You can just right away look at each of these 3 powers and say, this one's a positive exponent, and it's on the top. This one's a positive exponent, it's a 1. It's on the bottom. But this one's a negative exponent. You can rewrite the expression and just change all the exponents to positive as long as you move them from the top to the bottom of the fraction, or vice versa. So you can leave this x on the bottom. That thing can stay there. You can put this on the top, or you can leave this on the top, x to the 3rd. But the thing that's in blue there, that can go on the bottom instead, as long as you do what to the exponent. Instead of having x to the negative fifth on the top, you can make it x to the positive fifth on the bottom. If you want to write it nicely, you can leave this, you can make this go more in the middle, I guess. It makes you feel better. So that's the change, right? This thing on the top with a negative exponent is the same as that with positive exponent on the bottom. Two different ways to do it. You're going to get to the same answer either way. If you simplify that, then on the bottom here, x to the fifth and x to the 1, you could actually just make it x to the sixth, and you could leave the x to the third on the top. All right, so we've got a couple steps already. We're not even near there. Two ways you could do it from this way down is you could subtract, right? So I'm going to split it again here. A couple different ways. I want you to realize there's more than one way you can do this, right? You could just subtract this and say that that's equal to x to the 3 minus 6, or in other words, x to the negative 3, or in other words, 1 over x to the 3. That's one way to get there. Or you might just say, if I have 3 of them on the top and 6 of them on the bottom, if you imagine it, you don't have to write this, but if you imagine that you have the 3 of them on the top and the 6 of them on the bottom, what happens with, I can't really fit, maybe we'll make some more space there. If you have 3 of them on the top, 6 of them on the bottom, you can imagine that 3 of them are going to cancel with 3 of them. You're going to be left with 3 on the bottom, x to the third, and you got to have something. You can't have 0 on the top when you divide, and you get there that way. Either way, whatever works for you, right? Remembering to subtract, or just thinking of it this canceling way. 3 on the top, 6 on the bottom, you're left with 3 on the bottom. Hopefully that makes some sense. Now this third expression down here, over here, let's do this one. If we're trying to simplify that thing, make this a bit bigger first. Move it down here, and we can maybe have clean slate there to start with. If you're trying to do this again, there's going to be, not everybody's going to kind of approach it the same way. Some people would say, I'd rather work on inside the brackets first, so they're going to change this thing. 2 times x to the negative 2, or maybe let's highlight it separately. 2 times x to the negative 2 is the same as 2 divided by x to the positive 2. So you can change inside the brackets to that if you want, and then just leave the 3 out there. Multiplying by x to the negative 2 is the same as dividing by x to the positive 2. And negative exponent is like reciprocals. It's like division instead of multiplication. Okay? 2 to the 3 means you're multiplying by 2 3 times, right? 2 to the negative 3 means you're dividing by 2 3 times. You're not multiplying. Negative exponents mean division instead of multiplication. So you could do that to start with. You could raise each of those things to that power, 2 to the 3 and x squared to the 3. And then you could say the top 2 to the 3 is 8, and x squared to the 3 is x to the 6th. And that's about as good as you can do. Or you could do this another way. Right, so we'll start again here. 2x to the negative 2 to the 3. Some of you might say, hey, I would, instead of changing that thing that's inside there, I know that if you have 2 different things in here, whoops, I guess I should stick with the way I colored it before. Get rid of that yellow shading. Put our 2 back here. Let's make this yellow like we did, and this blue. If you have 2 things in there like that to the 3, you could just make each of them to the power of 3. 2 to the 3 and x to the negative 2 to the 3. That's the other way you could start, right? Right, you could do that. You could do each of those things to the 3. Oops. If you do each of those things to the 3, then just write out what each of them is. 8 x to the negative 6th. And this is where you have to change this. If you have 8x to the negative 6th, 8x to the negative 6th, multiplying by x to the negative 6th is the same as dividing. 8 times x to the negative 6 is the same as 8 divided by x to the positive 6. same thing. Okay, those mean the same thing. So any way you get there, there's a lot more than one way to get to kind of the simplified version of this. Those are just 3 examples. There's tons of examples in your study guide for you to work through, but hopefully that helps.